Okay. It's like I've never done this before. I do it every day. Okay. Here we go. I think we're ready. So in terms of review, we ended off talking about how do we draw a line. Now for us, it's not super important. So what I want to do is just walk you through the steps again, but also just show you how to use Desmos to draw your lines. Like I said, it's one of those skills that you're expected to have leaving this course, but for our purposes, it doesn't, we don't really need it because you're not handing in handwritten work. So for some quick review, right? I can't remember what we did before then, but we were talking about sketching linear equations, just a fancy way of saying straight lines. Straight lines, which have the form y equals mx plus b, right? Where m is a slope and b is the intercept. Okay, so what I want to do in terms of review, I want to just go through an example. I want to do example 54, and we're going to sketch the graph. Sketch the graph of 4x plus 5y is equal to 2. So I'm going to review the steps of sketching a graph, and then I'm going to show you how to use Desmos to do it, because that's how we will be doing it most likely. Okay. So step number 1 is I like to have it in the form of y equals mx plus b. So I'm going to solve for y. You don't have to, but I think it's easier to get it into y equals mx plus b form. Okay. So I have 4x plus 5y is equal to 2. Now solving for y, right, I'm going to move everything over that's not y over to the right-hand side. And so I get 5y is 2 minus 4x, right? Subtracting 4x from both sides. And then what I have to do to get y on its own is divide both sides by 5. So then I get y is 2 minus 4x over 5, right? It'd be so nice if 2 and 4 were divisible by 5, but neither of them are, right? So we're dealing with fractions, which is kind of annoying, right? So, or we can write y is 2 over 5 minus 4 over 5 times x, right? As long as you're keeping this denominator on both of the terms, you're allowed to split it up, right? Because then you have that common denominator. Let's see if I can. Okay. So I'm going to use it in terms of the fractions here. So that was step 1, solving for y. So now step 2, I'm going to find 2 points on the line, right? So just any 2 points, I pick 2 values of x, and I like to choose convenient values of x. In this case, convenient would mean what? It would mean that it's divisible by 5, right? Because then the 5 at least would go away. I still have to deal with this 2 over 5, right? But at least then I could get rid of this 5 in the denominator, right? So that would be a convenient value of x for me. But that's going to take, just kind of time and practice. So next thing we do is find 2 points on the line. How I set it up is I like to have an x category, okay, and then I have y equals 2 over 5 minus 4 over 5x. So then I'm going to solve for the value of y at that point of x. And then the result is going to be some XY pair. Okay. And that's the point that I put on the line, or that's the point that's on the line that I draw on the graph. Okay, so my go-to convenient value of X is 0, right? I like to use 0 because it's easy to plug in here. 0 makes this go away. And so then Y is just 2/5. No one likes fractions, right? But, or 0.4 if you prefer. So then the first point on the line in terms of an ordered pair here is when X is 0, Y is 0.4. I'm going to use the decimal version just because it's a little bit easier for our minds to graph. And then, like I said, I'm going to choose a convenient value of X here. Okay. And so I have 5 as a convenient value of X because 5 divided by 5 makes 1. So then I'm just left with 2/5 minus 4. Okay. Which is, so Y is equal to 2/5 minus 4/5 times 5. But these cancel out. That's what makes it a convenient value of X, which is really just 0.4 minus 4, which is negative 3.6. Okay. So when X is 5, Y is negative 3.6. Now remember, I'm just drawing, and maybe I have, I feel like I have these little stickies I could use. Oh, maybe not. How do I? Shoot. Oh. Maybe like that. Gonna need it to be slightly larger. Okay. Hopefully this will work here. I'm going to put my y-axis here, and then my x-axis here. Okay. So then what do I need? What do I need to accommodate to draw this line? Well, I have x equals 0 and x equals 5. So I need to have those values on my grid. So 0's at the origin, 1, 2, 3, 4, 5. Y is going from 0.4, which I can draw it now. Let's say is maybe here, right, at 0 and 0.4. And then I need to go down to at least negative 3.6. So I'm going to try to go for negative 4. Let's see what I can do here. Negative 1, negative 2, negative 3. Oops. And I'll put negative 3.6 just on the bottom here. I've got a page break, so that's why I'm kind of strapped for space here, but that's okay. We're just sketching it. So when x is 0, y is 0.4, so I have that point. And when x is 5, y is negative 3.6. So I can put that point on there. So now what I'm going to do, right, step 3, and I'm going to keep it on this page here, is connect those 2 points and extend the line. And then we've drawn the line. Connect the points and extend the line. All right, and so here, maybe in orange. There. Now I've drawn the line just like we were supposed to. Okay. here, this is what we call a negative slope. Okay, and that's because the slope value itself, which was easy to see once we've solved for y, the slope itself is negative, right? So here we have this negative slope. So in general, you can have a positive slope, which means it's going to be going up into the upper right-hand corner, or you can have a negative slope. All things that are probably reviewed, but doesn't hurt to mention them. Okay, nice. So what we're seeing checks out with what we had here, right? The y-intercept is 2/5, that's what we saw, and then we have a negative slope, and we can do more calculations, but let's see how we draw this in Desmos. So what I want to do is I want to show you that you can just enter this equation here, or this kind of more complicated equation in this case, and get the same results. Okay, so let's see here. Where's Desmos? So you're going to use the graphing version, right? I'm working with two versions of Desmos. I use the graphing one for graphing, and then I just use the scientific calculator for anything else. Okay, so what I'm going to do is just take that equation that we were given initially, and I'm going to say, okay, 4x plus 5y is equal to 2, exactly as it was given. Okay, so some things that were given here are 2 points, right? And this is just Desmos saying, hey, here are 2 points that you might be interested in. So what I'm going to do is I'm going to zoom in here. And I can click these points, and sure enough, I see that the y-intercept is at 0 and 0.4. And then what I'm going to do, just to check my work, right? The other point I found was when x equals 5. So what I'm going to do is I'm going to take my pointer. So I'm just dragging my finger or my pencil in this case, right, along the line, make sure it's highlighted until I get to 5. When it's at 5, it's hard to hold it steady here. 5 and negative 3.6, which is exactly what we found, right? And so that's one way that you can check your work. Now let's see here. Oops. What I'm going to do is I'm going to draw a line at y equals negative 3.6. Because then it'll give me these points. And the only reason I'm doing that is because I want to do a screenshot to bring into our notes. We can use Desmos to draw lines instead. Or to check our work. Right? Well, that looks like a weird smiley face. We like checking our work. Okay. So here, right, we saw that these points match up with what we found. And so now I'm feeling confident with the line that I drew. In fact, I'm going to make this just a smidge smaller so it doesn't take up a ton of space. Okay, nice. So, oh yeah, the other thing I wanted to show you was that it doesn't really matter how you put the function in, right? So if you wanted to check your work, did I solve for y correctly, right? We had y is equal to, and you want to make sure that you make it look exactly like what we had, 2/5, right? And then you want to step it out because then you want to have minus 4/5, step it out times x. Right, so notice that the two are overlapping, right? I can click on the red one and it shows up red, and I can click on the green one and it shows up green, and that means that they're overlapping, right? So here. So here we can enter, oops. Oh my gosh. There. We can enter the equation of the line either way, right? And then we'll see that they're overlapping. Either way to see that they are overlapping. Oops. That's another way that you could check to make sure that how you solve for y is correct, right? We could also use this to make sure we solved for y. Make sure we solved for y correctly. Right. I always like to have lots of ways that you could check your work, right? Okay. So that's kind of the end of the review, although we didn't talk about Desmos last day, but today. So next thing I want to talk about is just functions. We're going to be dealing a lot with functions. And I remember when I was first kind of starting in math, I guess in high school, the idea of functions, I understood them. If I saw them on paper, I got it. But whenever someone said functions, I would just get nervous for some reason. And so I'm going to spend a little bit of time talking about functions because you might be comfortable with them, and that's great, right? But we need to be able to use functions and talk about functions. So functions in general take some input, so some value of x, and produce some output, so some value of y or f of x. Okay. So functions take a value of x, which you can call input, and return a value of y, which is output. Okay. Now here's the kicker. I think this is the part that used to confuse me the most, is that y is also sometimes called f of x. So depending on how you want to write things, right, as soon as I see an f of x, I tend to swap it out for a y, at least in my mind, right? Because I don't know, for some reason, solving for f of x, I don't know, didn't make sense to me. So you're going to read f of x as f of x. Okay, that's important because that's going to nudge you towards how to treat these things properly. Okay, so whenever you have something outside and then followed by a bracket and then something inside, you read the brackets as of. Okay? And so if I say something like, so for example, the profit of hours, right? I could write that. That means that I could input some number of hours that I've worked probably, and the result would be the amount of profit that I would make at that number of hours. So here, you're going to read profit of hours. Yeah. But it's really just the profit at that value of hours. The profit at that value of hours. Yeah. So it's good to have the lingo down. Yeah. So just as a note, right? We were solving for y equals mx plus b, right? But we could have just as well written f of x instead. So f of x is mx plus b, right? Because I can put in any value of x and I can find f of x, which we were calling y. Okay. But these two are interchangeable. Y and f of x are interchangeable. Let's do a quick example. If f of x is 2x plus 1, find f of 2. Fair enough, right? I want to use x equals 2, right? And so here, right, find f of x when x equals 2. So what I have then is I have f of 2 is 2 times 2 plus 1. 2 times 2 is 4, and then plus 1 makes 5. So f of 2 is 5. Notice that we already used functions without saying that we were using functions. Hey, that could be one of those stupid reels. Tell me you're using a function without using a function. Right, when we were solving for points on the line. So that's what we were doing. We were using functions. We weren't calling them functions, but they were, right? And so when x is 2, y is 5. Right. So we can draw this if we want to. Just a quick sketch, right? When x is 1, 2, 3, 1, 2, 3, 4, 5. When x is 2, y is 5. Let's do another example. This one's from the textbook. Example 57. We're going to let f of x be 3x plus 1. I want you to find f of 10 and f of negative 5. Just give you 1 minute to work through that. started on f of 10. Nothing crazy here. I like to just write out the original function at first, and maybe I shouldn't have 10 here. I should just have the generic x. And then below it, I'm going to fill in the values of x. So f of 10 is 3 times 10 plus 1. So f of 10 is 30 plus 1, which is 31. One thing that you can kind of leverage here as we start to work into kind of more involved calculations, if nothing's changing on the left-hand side or on the right-hand side, you don't have to write it out every time, right? If there's a change, then you would write that change, but because there's no change here, I'm just going to leave it. Same thing with f of x is 3x plus 1. So f of negative 5 is 3 times negative 5 plus 1, which is 3 times negative 5 is negative 15 plus 1, negative 14. Let's do an example with a profit function. We haven't seen a profit function, but we suspect that's why we're here in business math, right? Is we're going to be talking about profit, but also just kind of how do we manipulate a profit function, that kind of thing. And so let's see here. Example 60. We're given the profit function of x is 45x minus 725. And we're going to let x be the number of hours worked. X can be a lot of things, right? It can be the number of hours worked. That's pretty typical. It can be the number of items sold. It can be the number of machines you have running, right? It just depends on how you make a profit. So for part A, I want to know what is the profit when x is 50. I'll write out the parts and then I'll bump them down. So if you're writing it out, then maybe give yourself, I don't know, 3 or 4 lines, probably 4 or 5 lines between each part, because I'm going to be bumping them down. But then we want to talk about how many hours to earn $0 profit. That's what we call the break-even point, right? Because at some point, right, there's kind of a buy-in to making profit. In this case, it's $725, right? I need to make up that $725. Until then, I'm making negative profit. It's better than negative 725, right? But it's not quite positive yet. Okay, and so here, this is the break-even point. When I start breaking even, right? And so where I start making a positive profit. And then we're going to use this profit function to figure out, okay, what if I have some goal profit amount, how many hours to earn $1,000 profit? So these are the questions that we're going answer, and I'll just start bumping them down and give you some time to work through A and B and probably C. Put them on down here. So whenever I work with these functions, and this is just me being ultra picky, right? I like to have the original function written first, and then unless I'm pressed for space, I know, so silly. Profit of X, 45X minus 725. Just because then I can see what I'm doing and what I'm working with. So what I want to find the profit when X is 50. So what is the profit, right? So that means I'm going to solve for the profit at X equals 50. So then I've got 45 times 50 minus 725. I have it here. 45 times 50 is 2250. Then minus 725 puts me at 1525. Maybe I'll make it a little bit roomier since I have space here. So 1525. We already know in part C that we're going to solve for how many hours to make $1,000 in profit. What do you know immediately about your answer, right? Just from what we just found. Well, it's going to be less than 50, right? Because at 50 hours, I made 1525. So if I want to make 1,000, it must be less than 50, right? So that's what we'll see. But that's just something to kind of think about to check your work. I'm all about checking your work, right? Does my answer make sense? Okay, so now I want to know how many hours do I have to work? So what is X, right? Now we're solving for X if I want to earn $0 profit. So here, again, the profit of X is 45 times X minus 725. I'm going to force the profit to be 0, right? And then solve for X. 0 is 45X minus 725, right? So here, how many hours is really saying solve for X. Okay, solving for X, I'm trying to shake X on its own. Wait, need to give myself a little bit more room here. Okay, I'm going to add 725 to both sides, right? Because first I need to move the 725 over. And so I get 725 is 45X. And then remember, I like to have my whatever I'm solving for on the left-hand side. So in the same move, right, I'm also going to divide 45 or divide by 45 on both sides, right? So then I'm going to get X is 725 divided by 45. Which X is 16.11 repeating hours, or approximately 16 point. Now here's where I'm going to do something weird, right? Because I can't work 0.111 repeating hours, right? That's hard to communicate. And so I'm going to say approximately 16.12 hours, right? Because otherwise I'm not going to make quite 0 profit, right? If I only go to 16, for example, then I make a little less than 0 profit, right? And so approximately 16.12 hours. Round up to reach over $0 profit, right? It's going to be a little over 0, but that's okay. It could be 11. That's totally fine. Except then, so 0.111111111, you'd still be just under 0. It's not a big deal, right? You could go to just 1, right? But here, I'll even add it. Or 16.11 hours. Yeah. Right. And so it's so minute, right? Even approximately 16 hours is fine, right? But we're just solving for X that makes the profit 0. Awesome. We're going to do the same thing, but for $1,000 profit, right? So we follow the same song and dance here, right? And so the profit of X is 45X minus 725. So now I'm forcing the profit to be 1,000. And so 1,000 is 45X minus 725. I have to add 725 to both sides. That's the same as always. And so I get 1725 is 45X. Now I do that same revolving door maneuver here where X is 1725 divided by 45. So again, we get a nasty repeating number, but that's okay. 38.33 repeating hours, right? Does that make sense, right? So we want to check our work. It does make sense, right? Because why? Because at 50 hours, like we said, we made a profit of 1525. So we knew it was going to be less than 50 hours, which 38.33 is less than 50 hours. But it's still kind of in the ballpark. So our answer makes sense. Nice. Okay. Let's see here. Okay. So one of the concepts that we need in order to deal with functions is this idea of the domain and range of a function, because there will be some values of X that are not allowed. Okay, and so there's some ground rules that we need to establish. And so I'll put it on a fresh page here. We're going to start with the domain. The domain of a function is all possible values of X. Is all possible values of X. Okay. Which means on the flip side, right, instead of looking at all the values that it could be, right, so all the reasonable values, what we do instead is we decide, okay, well, which values of X can I not put into this function? What gives me illegal math? Okay. So, oh, my Google is talking to me. I didn't say anything. I don't think I said it, but she's looking stuff up for me, I guess. A little bit creepy. Okay, so what we do is we find values that result in illegal math. That results in, I call it illegal math. These values are not in the domain. These values are not in the domain. All the other values will be. Okay? So what's some illegal math for us to keep us on our toes? There are only two rules that I need you to remember. Okay? We cannot divide by 0. So if you have a fraction with an x in it, right, then any value of x that gives you a 0 in the denominator, right, that's not in the domain, right? You have to pull it out of the domain. The function doesn't exist at that value of x. Mm-hmm. The second function, or the second illegal math, is that we cannot take the square root of a negative number. We cannot take the square root of a negative number. Yeah. So if you have a function that involves a square root and you have an x in the square root, right, any value of x that yields a negative number in the square root has to be taken out of the domain. Okay. So then the other idea that we need, they go hand in hand, is the range. Okay. Now the range is a little bit easier to think about because it's all the possible values of y that we could get. Okay. The range of a function is all possible values of y. Let's see, I was working on our Moodle page and I'm feeling pretty good about it. The timing got weird because the first week was weird, but let me take you there. Mostly because I want to see if I have maybe some practice problems here. So I posted the test dates, so you have those, and maybe I'll make it so I'm a student so it doesn't look so weird. All these secret things I have going on. Okay, so I added, and for future, because the textbook seems to be hard to find, what I've done is I've got the chapter problems and solutions, which is basically why you would buy the textbook anyways, unless you wanted more of an explanation. But I'm just going to see if there are some problems here that I want to do. Okay. There are. Some of these are harder than what we've dealt with, right? So this one, it's not very helpful for me right now. So let's just do a quick example. Find the domain, which is the hardest part. find the domain of y equals 2 over 3x minus 1, for example, right? So here, right, it's really important, we cannot divide by 0. So what I do is I set it equal to 0, and then the resulting value of x is what I pull out of my domain. Okay. So what I do is I find 3x minus 1 equal to 0. 3x is 1, so x is 1 over 3. X equal to 1 over 3 is not in the domain. Therefore, x can be any number except x equal to 1 over 3. Now what that looks like, right, we can graph this in Desmos if we want to see what it looks like. Okay. 2 divided by, and then in brackets, because I just want to make sure that they stay here in the denominator, 3x minus 1. So here, right, I get these, I get this asymptote, right, because x can't be 1 over 3, so things happen here, and I'm not going to worry about the range, right? But for us, it's important to keep in mind always, whenever we're doing or trying to do illegal math, this is what happens, right? We've got these asymptotes. Okay. It's enough on domain, right? You saw from my brief flash of practice problems, right? There isn't a ton of practice problems for the domain and range, which means it's not super important, but it is something to know for later. Okay. Kind of jumping into you know what? No, I don't want to do this. Mostly in the interest of time. And we're going to do it later, so I feel like it might be a bit overkill. I do, however, want to start section 2.2. All right. Section 2.2. So that was all 2.1, kind of still covering some math concepts. 2.2 is on supply and demand economics. Now, I've taken economics courses, or just a couple, but I'm not the one to teach you about supply and demand and how the curves shift or anything like that. So what we're going to focus on is we're going to find the point of equilibrium, right? The supply and the demand curve, equilibrium, that's what we're interested in. Really just the point of intersection of two lines, right? And so that's what we're going to focus on in this course, right? So, just in general, we're going to have curves that look like this, where we have price on the y-axis, which we denote by P, and some quantity of some item on the x-axis, which we denote by Q. Okay. Now, the demand curve has a negative slope. As a negative slope, right? if the price is high, then the quantity in demand is low, right? If as we lower the price, then the quantity in demand is high, right? Whereas on the flip side, right, depending on where you are in this business, we've got the same items on the X and the Y axis, the price and the quantity, but the supply curve is going to have a positive slope. So the supply curve, can't write curve to save my life today. Curve, the supply curve has a positive slope. Right? Makes sense. If you're the supplier, right, when the price is low, you don't feel like supplying very much, right? If the price is high, you feel like supplying a ton, right? And so then how you think about the quantity depends on which curve you're on, right? The supply and the demand curve. Now, the point of equilibrium, right, is where these two lines intersect. The point of equilibrium is where these two lines intersect. So now I have a curve like this. I've got the price, which is P, and the quantity, Q. And I'm going to have some supply curve and some demand curve. And this point where they intersect, this is where everyone agrees, right? This is equilibrium. So what we're going to do, right, is we're going to find the value of P and the value of Q at that point of equilibrium. What does that sound like? Sounds like we're solving a system of equations, which we are. So here, there's some Q at equilibrium and some P at equilibrium. So what I'm going to say is since S and D, right, they're straight lines, so they're just linear equations. So S and D are linear equations. We can solve the system of equations to find the point of equilibrium. We can solve the system of equations to find the point of equilibrium. Oops. Let's do an example. And maybe before I do, right, it might be helpful if you replace, right, or at least in your mind, right, replace the P's with Y and the Q's with X, right? Because Q's on the X-axis, P is on the Y-axis, right? So it might be helpful. Oops. It might be helpful to think of P equals Y and Q as X. We're going to find the point of equilibrium when the supply curve is Q is equal to 2P. And the demand curve is when Q is equal to 10 minus 3P. This is nice, right? Because they're already solved for Q. So what can I do, right? I'm going to use substitution, but I don't have to do very much work here because they're both already set to Q. And so what I'm going to do is I'm going to take 2P and set it equal to 10 minus 3P. So here, call this equation 1 and 2. So what I'm going to do is I'm going to substitute 1 into equation 2. Q is 2P, so then 2P equals 10 minus 3P. Now I'm going to solve for P. 2P minus 3P, I'm trying to get P on its own, so I'm going to move this 3P over to the left-hand side, so I get 5P is equal to 10. So P must be 10 over 5, which is 2. If P is 2, then Q, right? We have Q is 2 times P, which is 4. Or 10 minus 3 times 2, which is 10 minus 6, which is also 4, right? So they have to match up, right? That's what the point of equilibrium is. So now, solve for Q. Q is 2 times P, which is 2 times 2, which is 4. And just to check, Q is 10 minus 3 times P, which is 10 minus 3 times 2, which is also 4. Right. So you can always check, they should be at the same point. So therefore, the point of equilibrium is when Q equals 4 and P is equal to 2. P is 2, Q is 4. All right. How can we solve these just using Desmos, right? As long as we make the substitution that X is for Q and P, Y is for P. So here, or solve using Desmos with X is equal to Q and Y is equal to P, right? Just making sure that you keep track of those. So then the first line, right, becomes, I'm going to copy this, paste. So this becomes, I'm going to erase these. The supply curve is X is equal to 2Y. And the demand curve is X is equal to 10 minus 3Y. Okay. That's what I'm going to take into Desmos. And I'm pretty sure, I guess we'll find out, but I'm pretty sure I can just write this into Desmos. Let's see here. x is equal to 2y. So far, so good, right? That's my supply curve, I think. Yeah, that's the supply curve. Now the demand curve was x is equal to 10 minus 3y. Okay. Oops. Now that point of intersection here, I want it here so I can crop the screenshot. There. As long as you remember, right, this intersection is the point of equilibrium, right? So that's what we're solving for. And x is the quantity and y is the price, right? And so here, Q is 4 and P is 2, right? You can use it to check your work, or because you're in an online section, you can use it to do your work, right? So it's worthwhile exploring. And in those practice problems that I posted, you've got quite a few here to work on, the section 2.2 problems. But I think when you're using Desmos, right, once you get the hang of it with the solutions there, then you'll be off to the races. And it'll be fun almost. Okay. Oops. Jumping to the wrong thing. Okay. I just started a fresh page, but it's a new section, so I wanna boop, boop, boop. 2.3. And we're able to move quite quickly through these sections because we're using Desmos. Otherwise, we'd have to be solving them, and then I would do more practice. But because you have Desmos to rely on, then I don't feel so bad. And especially for this next section. So linear programming. Linear programming is a pretty fun field of math. And what we do is we have some function, and in this case, it's going to be a profit function. And I want to maximize my profit function, right? And so linear programming is all about, with many different inputs, right? How can I maximize this function? So a downside though is, okay, sure, if I can, let's think of something fun. Okay, so one of my things that I enjoy doing is I crochet, but I crochet little animals. And so it's called amigurumi. And if you haven't heard of it, it's super fun. And so I crochet these little animals. Let's say I'm going to sell these animals. I can only produce so many, right? I can't produce an infinite amount in a week, right? And so let's say I can only produce, if I have it down to not just for fun, it doesn't sound fun anymore, right? Maybe I can make 5 in a week, right? And so we have these restrictions on how much profit I can make, right? And so linear programming takes into account those restrictions as well, and then we want to maximize within those restrictions. And so how I'll start this here is we often have restrictions on our profit function. We often have restrictions on our profit function. Right? Things like time, materials. Time is usually a big one, right? So how much can I do in a week, right? It's not infinite. If it was, then sure, my profit function, you can just put it through the roof, but that's not the case, right? Machinery, maybe I only have 2 machines, right? Labor, kind of, etc. You can't work your laborers for 24 hours, you just can't, right? So even though in theory, right, you have this labor, right, you have some restrictions on it. So linear programming will let us maximize a profit function, will let us maximize a profit function given a set of restrictions. Yeah. So just so we know what it's going to look like, right? I haven't talked about how we are going to do this linear programming, right? But just so we have an idea of what it's going to look like. For example, if I have a profit function is 3x plus 4y, so this looks a little bit different than the profit of x because now I have inputs of x and y, right? So I'm allowed to take into account multiple variables. We're only going to look at 2, but right, because I could have restrictions on time, materials, and the number of machines, right? And so it just depends on what X and Y are. So in this case, maybe for example, this is time, and maybe this is the number of machines, for example. Okay. So I have a profit function, and then I've got these restrictions. X is going to be greater than or equal to 0. I cannot spend negative time creating these items, whatever they are, right? And so same thing with y. Y is going to be greater than or equal to 0. Okay. Graphically, what this translates to is you're going to have a graph like this. Like this. And what that means is X has to be greater than or equal to 0, which means on the graph, oh my gosh, I did it for the wrong one. X is 0 here, right? At the origin. So this restriction just looks like this, right? So I'm on this side of the x-axis. It'll make more sense once we talk about, you know, what these restrictions do and how we use them. But y greater than 0 means that I'm restricted to above the x-axis. So these are our graphical restrictions as well, and that's how we're going to use them. An additional restriction that we might have is X has to be less than or equal to 4. I only have 4 hours a week to spend on this thing, maybe. What does that look like? X equals 4. Let's say here, right? X equals 4. And maybe no arrow. Sorry. I'll make it straight. So sloppy there. So X has to be less than or equal to 4. I only have 4 hours to spend, or I only have 4 people working for me, which means that, right, I'm restricted to this area of X. So X has to be between 0 and 4 is what this is saying. I'm also going to have restrictions on Y. But on the other side, so Y, let's let Y be less than or equal to 4 as well. Color haven't I used? Pink. Okay, so maybe here at Y equals 4, right? Y has to be less than or equal to 4, which means that I'm restricted to this area. I'll clean this up. Okay. So now I have this area of X's and Y's where I can reasonably work and I can find a profit function, right? Everything outside this area, right, it's not going to work in my profit function. And so to maximize a profit function, or let's take it a step back here, right? So here, now I'm in this region. This region satisfies all the restrictions on X and Y. All the restrictions on X and Y. So any point in this region can be used to calculate the profit, right? Because I'm allowed to have, because in here, every single point, right, is an XY coordinate. And so these can all yield profits and just varying levels of profit. Every point in this area can be used to find some level of profit. To find some level of profit. But our goal is to maximize the profit. But we want to maximize the profit, that we understand, right? But we want to maximize the profit. So that's where linear programming comes in. Okay. And so we're going to do a baby version, of course, of linear programming. But how do we maximize this profit? Okay. So I'll start it on a fresh page here. How do we maximize the profit? Given some restrictions. Given restrictions on, we're only going to deal with X and Y. If you did a linear programming course, then you could look at many inputs, but for us, we're just going to have X and Y. Okay. So the first thing that we're going to do, because this is the question that we're answering, is you're going to draw the restrictions on a graph. Now, for us, we're going to use Desmos. draw the restrictions on a graph. We will use Desmos. When I do this course in person, then of course, because in-person test, we can't use Desmos. So then you have to draw it all by hand. And so that's why you would need to know how to draw straight lines properly, but we kind of glossed over that, right? But we're going to use Desmos. So you have to take all the restrictions and translate them to the graph. Okay, so now, next thing you're going to do is, I like to shade the feasible set. Like it's called the feasible set. And so here, that's this region, right? All the values that satisfy the restrictions on X and Y. And so this is the feasible set. Shade the feasible set, right? All the values of X and Y that satisfy the restrictions. Or maybe I'll say the area on the graph that satisfies all restrictions. Okay, because those are all the XY combinations that I could put in and I could find a profit, but we want to maximize it. Now, here's the fun part. The fun part is that the profit will be maximized at one of the corners. Okay, so one of the corners of the area of the feasible set will maximize the profit function. So the profit, and maybe I'll start with the fact. The profit is maximized at one of the corners. You could have a tie, right? But usually we don't. So one of the corners of the feasible set, which is really one of the intersections. Yeah. So what we do is we make a list of all the intersections, right? All the corners in the feasible set. So we're gonna make a table. Let me see here. Here, because this was just a fact. This wasn't actually a step, I guess. But we're gonna find all the, why isn't it? Find the all points of intersection. Then now the calculations start coming, okay, but they're not major by any means. Okay, so once you have the points of intersection, you're going to make a table. I find that that's the cleanest way to do it. Make a table of all points of intersection of all ordered pairs. Ordered pairs right? XY combinations of all the points of intersection. Then, just like we did when we made a table of X values, and then I plugged them into Y to find the ordered pairs for drawing our straight lines, kind of similarly, we're going to calculate the profit at each of these XY combinations. Calculate the profit at each XY combination. Once you have those profits, knowing that it's maximized at one of those points, right, then the largest profit that you found is the maximized profit. So the largest, which is maximized profit, is the optimal solution. That's the solution that you want. Okay. Okay. So in terms of this example that we started with, right, this little baby example, okay, we had these restrictions, and then we went through and we drew those restrictions on our graph, and then we found the feasible set. What's the next thing I could do? Okay. Here, I'll just grab this. Copy. Paste. So we have these restrictions, and can I erase that? So we already did step 1 and step 2, and I'll show you how to do it in Desmos too. But these lines are so easy, right, that it doesn't make sense, but that's okay. So then we said, okay, the profit is maximized at one of the corners of the feasible set, which means I have to find what those corners are. Okay. And so in this case, it's just a rectangle, right? And so here I've got, let's see if I can find a different color I haven't used. How about this cute purple? So here I'm at 0, 0. Right, that's one of the corners. I could just do nothing, and that gives me some profit. That's never going to be the maximized profit, but it does exist, right? And so it's never maximized, but we do it anyways. This value here, this top corner, is when x is 0, y is 4. This corner is when x is 4 and y is 4. And this corner is when x is 4 and y is 0. Right? So now we can make a table. Oops. Make a table of these ordered pairs. So I've got my XY pairs. I like to use just kind of starting at the origin, and then I list them going clockwise. Yeah, clockwise. Just to make sure I don't miss any. 0, 0, 0, 4, 4, 4, and 4, 0. And that's when we go back to this profit function, right? 3x minus 4, or sorry, plus 4y. So the profit is 3x plus 4y. Notice that we haven't talked about 3x plus 4y until now, right? So we work with the restrictions, and then we calculate the profit. Okay, 3 times 0 plus 4y, 4 times 0 is 0. It is an option for the profit. I don't want it. That doesn't sound good to me. How about 3 times 0 plus 4 times 4? That's 0 plus 16 is 16. That's better, right? Much better. 3 times 4 plus 4 times 4. Hey, that sounds great. 16 plus 12 is what, 28? And then 3 times 4 plus 4 times 0 is 12. Right, so here, this is the maximized profit is 28 at x equals 4 and y equals 4. Nice. Okay. 28 units, right? Doesn't matter. Just a baby example. Let's do a real example. We want to maximize the profit is x plus 1.2 y. Now, I'm just gonna duck back in and check how, okay, so they're using, so in these problems, it doesn't say profit, it says P, and it says subject to instead of restrictions. I'm gonna use that same terminology, so I'm gonna switch this. I remembered. Maximize P, which is profit, right? Just making a note, making a note here. Subject to, which is just restrictions. Subject to, we're going to have 2x plus y is less than or equal to 180. X plus 3y is less than or equal to 300. And x is greater than 0, greater than or equal to 0, and y is greater than or equal to 0. These restrictions are always going to be in there, and it just means that we're working in the first quadrant. So these will always be restrictions. Right. We will always be working in the first quadrant. Right, if you're thinking about kind of your XY plane, right, then the first quadrant is where they're both positive. Okay, so we don't really need to draw those, but let's take this to Desmos and see what happens. And so again, I can't remember exactly how Desmos works, but I'm just going to try to just try to plug this in exactly as it shows up and see if it works. So 2x plus y less than or equal to 180. Otherwise, we might need to do some work, but I'm hoping not. So now I have 2x plus y And notice that there are inequalities down here, right? And so it's going to be less than or equal to 180. And notice that it shades it because it's an inequality, right? So that's really nice. We're going to have to zoom out a bit. 180 is quite large. Okay. And so far, so good. Great. Now, the next one is x plus 3y is less than or equal to 300. Okay. If you want to, you could add in x greater than or equal to 0 and y is greater than or equal to 0. I'll show you just so you have it. Is greater than or equal to 0. But that just puts you on the positive side. And y is greater than or equal to 0. But it just makes a mess, right? So for us, we're just always focused in that top right-hand quadrant, the first quadrant. And so I'm going to remove these and just remember that they are also restrictions, right? So let's see here. Oh, I wish I could have these. I'll remember that that's at 0 and 100. That's easy to remember, right? But then I want to have these intersections because I can't have all three, it looks like, showing at the same time. And so, come on. I lost the points. Okay. There. How come I'm losing them when it was keeping them before? Hey. All right, fine. I'll just have to remember what they are. Try one last time. Now it worked. Good thing I tried. Okay, so then here, finally, I'm going to just crop this up a little bit. So remember that we're only interested in this area, right? So we're remembering that because it just makes it too ugly to look at otherwise. Okay. And this point of intersection was when x is 0. Oh, that's a bad color. Y was 100. You don't want to forget about the 0, 0 option, right? So down here, 0, 0 is also a corner. It'll, like I said, it'll never maximize your profit function, but you have to include it. Okay, just like that, we have the points of intersection of our feasible set. So here, right, our feasible set is this area where they all overlap. Yeah. So here, right, our feasible set looks like this. This is our feasible set. And we have all the corners of it. So now what I'm going to do is I'm going to make a table, right? And just to highlight here, I just entered the restrictions as they were given, right? So now I'm going to make a table of my x, y coordinates. And again, just to be working methodically, I'm going to start at 0, 0 and work my way around. So 0, 0, 0, 100, 4, 48.84, 90, 0, and then that's it. Just count to double check. 1, 2, 3, 4 corners. 1, 2, 3, 4 corners. Okay. If we were not using Desmos, how would you find this point of intersection? That's a system of equations, right? We don't have to, but might be fun for practice. Okay. This is the first time our profit function makes an appearance, right? P is equal to, we don't even remember what it is, x plus 1.2y. So when x is 0 plus 1.2 times 0, the profit is 0. No surprise, right? Let's see here. When x is 0 plus 1.2 times 100, I get 120 in profit. Better. Okay, let's see if we can do a little bit better. 48 plus 1.2 times 84 is, let's see here. Oh. Just gonna check it. 48 plus 1.2 times 84, 148.8. Okay, good. 148.80, because it's money, right? Profit. That's the best one so far. Let's try 90, 0. And so let's see here. X is 90 plus 1.2 times 0. It's a profit of 90. Not good, not great, right? Not even the best, or not even the second best. So here, right? This is the one I want. So the profit is maximized at x equals 48 and y is 84, and the maximized profit is 148.80. The maximized profit, maximized profit is 148.80, or whatever units, when x is 48 and y is 84. Neat. Yes. So it's just a fact, a fun fact is that the profit is maximized at one of those intersections, because you want to be at one of the extremes. So that's a fact. And that's linear programming, folks. So it really helps when you have Desmos, because then you don't have to draw these lines. You don't have to solve for the points of intersection, right? We just need to know what we need to do to maximize that profit function. Okay. Awesome. Hey, you guys did great. I don't even feel bad ending a little bit early because, well, I never give you a break, but also that was a lot. That was a lot of material, right? So that concludes section 2.3, right? Linear programming. But like I said, I posted these chapter 2 problems on Moodle, chapter 2 problems and solutions. So you can work through those, right? And just go through, oh, there's a blank page here. Go through 2.3 and just make sure that that's all working out. Okay. And then, so now we're done with chapter 2, just like that. Easy peasy. We're going to skip 3.1 and 3.4, just because the first week got weird. And so I axed those. Okay. But so next week, we're going to do section 3.2 and 3.3. And you'll have a quiz. It'll open on the Wednesday and it'll be on 3.2. Okay. If you have any questions, let me know. Otherwise, I'll stop this recording. And I guess have a great weekend. This schedule's so weird. See you on Monday.